Hey guys, welcome back to AlgoYogi. We are doing array and hashing series, and our next problem in the list is find words that can be formed by characters. So let's go to LeetCode and give this problem a read. So you are given an array of strings called words and a string called chars. A string is good if it can be formed by characters of chars. Each character can only be used once for each word in the array words. So now we need to return the sum of lengths of all good strings in words. Alright, so I have taken the first example here. We have words and then we have chars. Now we need to return the sum of the length of all the words that can be formed using the characters in chars. And remember that we will use chars once for each word. So it's not like if I create cat using, so we have been told we can only use the characters at least just once. Each character can only be used once. So let's say if I'm creating cat using this, that doesn't mean C and A and T are gone for BT. That will be an independent operation in itself. So that we have been told. So I think brute force or optimize approach, I think the most straightforward approach that we see for this problem is we want to actually create the hash map for this. So we want to count the frequencies of chars, and then we go to each word, then create the frequency map for this each word, and then check if there is any key that's not in the chars for that word, or the frequency of that character in chars is basically greater. So this is what we will do. First we will create let's say char map. So for this I'll create A appears twice, and then T appears once, C appears once, and H appears once. So this is the map, frequency map we will create for chars. Then what we will do is we will go through each word. So we'll start basically a for loop. So for word in words, then I will create a word map. So let's just call it word map, and we can just use in Python, you can use the counter to send in the word, and that will give you the frequency map. This is an inbuilt function. All right, now what I want to do is I want to go over all the frequencies of each character in this word. So let's say for key in word map, or you can just say dot items, right? You can just, let's say this value, I can just say value key and val in this items. What I want to check is if this key not in my char map, if that's one case, if this is not, or another case is if this if this value, let's say if this value is actually greater than the char maps key, so that then also we cannot create this, right? Okay, so here's the thing, if that's the case, then we can say we can break out, or maybe we can have a flag, let's say good word. Initially we'll mark it true, and here if that's the case, then we will mark at this position we will mark it this good word equals to false, and break from here, and then in the end you check if still good. If good, then you can add to your result. We will have something called result, initially 0, and then at this place right here we can add result plus equals to the length of that word. All right, that's it. That will be the entire solution, and then in the end we can just return the result. This is stupid. Return the result. All right, so for this solution the time complexity would be, first when we create this map, so that uses n time complexity, and then for each word, let's say the length of the word is let's say the length of words array, let's say we can call it W, and then for that we go through all the frequencies. So when I'm creating this counter, then I'm going through all the words. So you can say for each word, you can choose the longest word from this this array of words. So you can just say multiply with L. So that would be the time complexity. And space complexity is also going to be actually first is this, so N plus then W. Not W, actually it's L, because that at max you will be storing this word at max for you are reusing, you're not doing it, you're not creating and leaving it there, so you are reutilizing. So this will be N plus L. All right, that's all. Let's code up our solution. Awesome. So first thing first, I'm going to use counter. You can create the dictionary yourself where you count the frequency of each character. So, but I'll just call it char map and just use counter. If your interviewer asks you to like not use any inbuilt method, then you can go ahead and do this simple, create an empty dictionary and then keep incrementing the count. Then I will declare result initially 0. Then I will go through all the words. So word in words, I will create word map. Word map will be counter word. Then we're gonna go through all the key and val. So key and val in word map dot items. Then what I want to do is if key not in this key that exists in word map, if this doesn't exist in my char map, that means we cannot create that word using the characters in char map. If that's the case, or the value, the frequency of this word map for that character, for that key, if that value is actually greater than the value in my char map, so then also I cannot create. If it is equal or less, then I can create it. But if it is greater than what is present in my char map for this key, then also I can't create it. Then I will say okay, yes, we forgot about mentioning a good word. Good word is true. That's a flag I'm using. Good word, I think, yes, small characters. So here I'll say if that's the case, that it's not a good word, then we also break from here so that we can visit the next word. So this break will break out from this loop and then go back to the outer loop. But if you come out of this for loop and then if this is still true, good word is still true, because you went through everything and you saw that all the frequencies of each character is less than or equals to frequencies for that character present in char map, then it's still a good word. So I'll just into my result I will add the length of that word. All right, so that will be all, and in the end I can just return I can return my result. So let's zoom out and test our code on test cases. Let's submit, and then we can start writing the time and space complexity. All right, so before I write that, I want to write that n is the length of chars. Then let's say w is the length of the words array, and then L is the length of the longest word. Now time complexity, if that's the scenario, then time complexity is going to be, first we create that map, so that this statement, this line takes big of n time complexity, and then this in itself together, for each word we are going through that word, and if that the longest word is like L, then you just multiply n with w with L. So that's the time complexity. For space complexity, we are using this space. First is this space that we are using, and then we are using this space. So we can just say for the longest word is L, then we're gonna say it's going to be n into L. N into L. All right, so is it going to be n into L, or I think it's n plus L, because it's outside. It's storing for each char map. It's n plus L. So that is it. And this multiplication, I think, better represented with dot. All right, so that is the entire code. That is the entire code. Now let's go back to AlgoYogi, mark this problem solved. See you guys later in the next problem.